Hello, in this tutorial I am going to talk about the relationship between one-dimensional array and pointers. Now there is an implicit relationship between these two and we need to study that carefully. Let us consider this example where I have declared one-dimensional array X and initialized the array with these values 10, 20, 30, 40 and 50, and I have drawn a block diagram in order to represent the array in memory. Now the fact is that array is contiguous. We know that from the definition of the array. That means all the elements of the array are allocated one after another contiguously in the primary memory. If the first element is allocated here at address 5000, then obviously the next element is at 5004 because each element is integer element and integer takes 4 bytes of space. So the third starts from 5008 and the fourth starts from 5012 and the last one is at 5016. Now always implicitly the base address to the array is assigned to the name of the array. That means the name of the array is always by default going to contain the base address of the array. Base address is actually the address of the first element. So here the address of the first element is 5000. That's where the array is starting, so that will be kept by default in the name of the array. So the name of the array is always the pointer to the first element of the array by default. That means X is the name for this array, so X is the pointer to the first element by default. And since the array is integer array, so X is integer pointer to the first element of the array. That means on dereferencing using X, it's always going to be 4 bytes. Therefore, if I just go ahead and write something like this, say X plus 0, then it's actually 5000 according to this example. And if I just add 1 with X, since X is integer pointer, therefore adding 1 will actually increase 4 with X. That means it's going to be 5004. That's the address of the second element. You can see that if I go on and add 1 with X, always what I get is the address of the second element. And if I go and add 2, then it's going to be obviously 5008, and that's the address of the third element, starting byte number for the third element. So X plus I is always address of the ith element of the array. Now if I just do the dereferencing, say I'm writing X plus 1 and then I'm putting a star, then what happens, it's going to give me the content of the second element. Now X plus 1 means it's 5004. If we add 1 with 5000, it's 5004. Therefore putting a star, that means dereferencing 5004 will get us the value at second element. That means it's 20. So X plus I or X plus I star is going to give us the content of the ith element. You can see that if it is X plus 2, then it's actually 5008, and star of 5008 is going to give us actually 30. So X plus I star is always the content of the ith element. So there are two things that we get. X plus I is the address of the ith element, and star of X plus I is the content of ith element. Let it be a little bit fresh. Okay, I always love to erase. So is the fact that we get from the analysis, that is X plus I is the address of the ith element, and star of X plus I is the content of the ith element. Now before understanding pointers, we actually accessed the ith element by using the square brackets. That's the subscription operator. That means this was the technique to get the content or to manipulate the content of the ith element. Now we see that after learning pointers that these two things are just equivalent. What happens in practice? This third bracket is nothing but an operator. This is called the subscription operator. It operates on two operands, that is X and I. So what it does, whenever we are using this subscription operator with the index I, then it actually converts this to X plus I star. This is the thing that is actually written in the object file, and this is the thing that the compiler writes. This is only for our convenience, the third bracket and the I index. Practically there is no index or indices with the array. It's the value that we add with the base address in order to get the ith element. So always the third bracket is converted to this expression star of x plus I, that gets us the content of the ith element. I is added with the base address, then dereferenced. So whenever we write this, it's converted to this. So the question is that if I write ix instead of x third bracket I, will it work? Yes, of course it's going to work, because in that case compiler is going to convert it to I plus x star, and these and x plus I star both are same, because a plus b is commutative with b plus a. A plus b and b plus a are equivalent. So I plus x and x plus I always going to get us the address of the ith element. In order to get the address of the ith element, what we can do from now is we will just use this x plus I, that's the address of the ith element. Earlier we did xi and we put ampersand. We prefixed ampersand with the ith element in this way, and that get us the address of the ith element. But now we will be using this one. They are same. So this is the theoretical discussion, and now I'm going ahead to show you the output by writing the programs by using all these in our program. So here we go. First of all, I'm just printing the base address, so %p, and then what I'm doing, I'm printing the base address once more by getting it from the first element. That means first of all I'm printing the content of x, the name of the array, and then I'm printing the address of the first element by using the ampersand operator. X0 is the first element, x square bracket 0, so ampersand x square bracket 0 is the address of the first element. They are going to be same. And if I just go on and print this x plus 0, that is also same. X plus 0 and x are just same, so it's going to be same. Okay, now let me just show you the output that this is going to be same. Here we go. You can see that x and ampersand x0 both are just equal. That means the base address is always kept in the name of the array. Now what I'm doing, I'm just writing a for loop in order to print the content of each element of the array. So here we go. So here is the for loop that's going to print the content of each element of the array. So star x plus I is the content of the ith element. We are using the pointer notation this time, the dereferencing operator. Okay, here we go. You can see that the array is printed 10, 20, 30, 40 and 50. Okay, now I'm changing the notation a bit, and I'm just using this. Say instead of x third bracket I that we used traditionally, this will work fine. If I write this, this is going to print from 10 to 50 without any doubt. That's printing. Okay, so I can just change it and can write I third bracket x. And this is going to print the content of the array as well, as I have already discussed. This is going to be I plus x star, so it's going to print the content of the array. Here you can see that it's same, no compilation error, nothing at all, because it's pure address arithmetic. We have used the pointer notations in order to access each and every element of the array. The fact is, number one, the name of the array stores the base address. Array is contiguous, so using the address arithmetic we can get the ith element of the array just by adding I with the name of the array. So if we add 1 with the name of the array, it's the second element. If it is 2, that is added with name of the array, it's the third element, and so on. And then using the dereferencing operator asterisk, we can get the content of the ith element. So star of x plus I is always the content of the ith element. And whenever we are using the square brackets, the subscription operator with the index for getting the content of a particular element of the array, it's always converted to star of x plus I. Thank you very much.